Okay, so today we're looking at 9-7. This is actually kind of a review for Algebra 1 because we're going to be talking about linear, quadratic, and exponential models together. Models just meaning they're graphs. So at the top it says I can choose a linear, quadratic, or exponential model for data. So first they want you to review. It says when should you use the elimination method to solve a system of equations. Place a check in the box if the response is correct, place an X if it's incorrect. This is actually going to lead us into 9-8, what we're doing tomorrow. And so that's why we're thinking about this elimination method in systems. So it says when the system has at least one equation that can be easily solved for a variable, that is incorrect. That's not going to be elimination. The next one says when you can use properties to add or subtract equations to remove a variable. So don't forget when we're doing elimination, we want to eliminate a variable or remove it. So that is the correct box. Number 2, it says to solve this system of equations by elimination, by what number would you multiply the second equation? So again, we're just reviewing because tomorrow we will be doing a systems of equations involving quadratics and linear. So what would we model the second equation by? Hopefully you would choose C, -2. If we multiplied this by -2, then that's going to eliminate our y value because we need a positive and -6. Here we have a negative. If we do a -2, this will become a positive and our y will eliminate. So here's the big important part of this lesson, I guess, is that these are what these lines look like. You need to remember what they do look like. So a linear equation is in the form y equals mx plus b. Don't forget, m is your slope and b is your y-intercept. So the difference in y values is constant. If you look at your y values, so if you're given a table, your y values will be adding or subtracting the same number every time. And then you need to know the basic gist of what this equation would look like on a graph, so it's just a straight line. The quadratic is y equals ax squared plus bx plus c. This is our newest one. And the difference of the y values is constant. The difference of the difference. I'm not really going to pay attention to that, though. That it's a little bit confusing there. We're going to kind of do a process of elimination with that idea, and we'll talk about that in a little bit. But just know that your quadratic equation is a U shape, or if it's an upside down U shape, it looks kind of like an N. And then last, what we talked about a while ago was our exponential equations. Y equals a times b to the x. The y values have a common ratio here. So in our linear equations, they had, if you would add or subtract the same thing every time. In our exponential equations, they're going to multiply or divide by the same thing every time. So it's a common ratio. Now, these are going up exponentially or they are going down exponentially, exponential decay or growth. But those are the things we're going to focus on, is that they have something I'm multiplying or dividing by or something I'm adding or subtracting by. And then by process of elimination, if it's neither of those, it'll be quadratic. But we'll talk about that a little bit when we get to the tables. First, they want us to graph each set of points and which model is most appropriate for each set. So we're going to graph the points and decide, is it linear, quadratic, or exponential based on what it looks like. So go ahead and graph each of the points for A, B, and C. And you decide, is it linear, quadratic, or exponential? Go ahead and pause the video and graph each of those points. All right, so once you've done that, we plotted 0, 0. Now be careful because these are going by 2s, so hopefully that didn't mess you guys up. This graph it's going by 2, 4, 6. So then 1, 1 is actually going to be right in the middle here. And then -1, -0.5. I realize that that's hard to reach, but just give me a good estimate of somewhere in there. And then 2, 3. So we went 1 hash mark to the left or right, 2, and then 1.5 up because we're going by 2s. So this one, hopefully A, you put exponential. This looks like an exponential equation. Okay. Then B, we plotted -2, 11. That was way up here. -1, 5 right in here. 0, 3, and 1, 5. And then we noticed that was curving around like a quadratic function. So hopefully you label that quadratic. And last but not least, -1, -2, 0, -1, 1, 0, and 3, 2 left me with a linear looking equation. So these, we're just basing off what they look like on the graph and deciding, are they exponential, quadratic, or linear? Okay. So next it says, it's not going to be able to all fit on this at the same time, but when the x values in a set of data pairs have a common difference, you can analyze data numerically to find the best model. You can use a linear function to model data pairs that have a common difference in their y values, and you can use an exponential function to model data pairs that have a common ratio. So this is what I was talking about just a little bit ago, is that if it's linear, we find a common difference in their y values, not in their x, in their y values. Okay, common difference meaning we are adding or subtracting. So if you want to put that add or subtract there. Common ratio meaning we are multiplying or dividing. And remember, we can always write division as multiplication. So that's probably what we'll mostly stick to, is that multiplication idea. So here we've got 3 tables. They said which type of function best models the data, use differences or ratios. So you're only paying attention to your y values. And we're going to see how much those change by. So if you look, the y values go from 9 to 5 to 1 to -3 to -7. So hopefully you realize a pattern that's going on between that. Look to see, is it adding or subtracting the same number? Is it multiplying or dividing the same number? Hopefully you notice that it's subtracting 4 every time. So we know that this is going to be a linear equation. Yeah, and they don't ask us for an equation. They don't ask us for y equals mx plus b, so we don't have to do that. However, if you were to have to do that, we would just put y equals, we have to look for the slope. Well, it's changing by 4 every time, so -4x plus my y-intercept. Wherever I have a y-intercept, my x is 0, so here is actually my y-intercept. It's at a -3, so I don't even have to put plus, or you could put plus minus a -3, but I'm going to put -3. Now, I know it didn't ask for that, but just a refresher for you, that's what that equation would look like. Now, b, this is where we're kind of going to do that process of elimination. So if we look from y to y to y to y, is anything happening? Can you find a pattern? Am I adding or subtracting the same thing every time? Well, here to here, I'm subtracting 0.25. From -0.25 to -1, though, I'm subtracting -0.75, so it's changing. So I know it's not a linear function. Then I want to look, okay, can I multiply or divide the same thing every time? Well, if I look from 0 to -0.25, anything that you multiply by 0 is going to stay 0. So I know I can't multiply. So then it's not an exponential function. So now I've done process of elimination. If I know it's not linear, I know it's not exponential, then it's got to be quadratic. Okay, they have no common difference or ratio, so that's why I know this has to be quadratic. There's our process of elimination. Go ahead and try letter C yourself. Pause the video and try C yourself. Okay, so hopefully you realize that you're multiplying by 2 every time. So this is going to be an exponential. That's a common ratio, so it's an exponential function for letter C. Last but not least, example 3 is asking us to graph. So it says the table shows the annual income of a small theater company. Which type of function best models the data? Write the equation, an equation to model the data. So go ahead and plot those points. Here we got 0, 18,254. So that's going to be about in here. 1, 18,730. 2 is 19,000. Ooh, I got up too high on that. To go down a little bit lower, because 19,000 is going to be in there. So here's about 19,000, and then even closer, and 20,100 something. Okay, so hopefully by this you can realize that this is going to be a linear equation. It's going up just slightly and looks like constantly. So you should circle A. That's our linear equation. And it says, write the general form of the equation for this type of model. So linear equations come in the form y equals mx plus b. Now, we need to find m and we need to find b. Well, they gave us b, so that should be easy. They said at 0, for your x value, your y value is 18,254. So plus 18,254. That's our b value. Now we have to find our slope though. So our slope, to do that, you can pick any of these 2 points to find your slope. Don't forget your slope formula is y2 minus y1 all over x2 minus x1. So I'm going to pick the first 2 points, 0 and 1. So I have 18,730 minus 18,254 all over 1 minus 0. So that is 476 over 1. So there's my slope. I plug that into my m value. So 476x plus 18,254. So that's how we would come up with that equation. Okay, so go ahead and get to work. Hopefully that's not too tough. If you have any questions, please ask Mrs. Joyce. She is the other Algebra 1 teacher. But go ahead and get to work on your homework from the book. Please be good to the sub. Thank you.